Hi guys, this is Faizan. Welcome to this session by Great Learning. So today's session is going to be the continuous part of the series that we are having right now, that is CP part 8. So you guys can check the other parts as well. While we wait for others to join, as I can see that others are also joining, can you quickly guys give me a confirmation in the chat section that sorry, you guys can hear me or not? Just quickly write a yes or no so that I can get. So great. So I hope you guys are fine, right? So you are following rules and regulations, right? And in the meanwhile, while we wait for the others to join, you guys can also check the Great Learning Academy, wherein we have 80 plus courses available, and after the completion, you know that you will get a certification as well, right? So great guys. So let's get started. So today is the session on CP, as you can see, and it's a part 8, right? So any new guys, if any new guys are here, so you guys can check that the playlist has been added to our channel, right? You guys can check all the parts there. Okay, so now quickly before we start, can you guys quickly, thank you guys, thanks a lot. So yeah, before we start, can you guys quickly just give me a number, how many questions you have solved quickly on Lead Code or Geeks for Geeks. So where to find the other parts of CP you upload. So it will be in the playlist. Once you will subscribe to our channel, then you will get there and you will get all the videos and the playlist that has been added there, right? Thank you guys, thank you. So yeah, so quickly just write how many questions you have solved. Kuldeep, Sanaf, Ajay, great. Arjun says 4, Sanaf says 0, Afreen, Deepa, Afreen says 8, okay, and Ajay, all the guys, just quickly give me a number. No questions till now. Sanjay, Sanjeev, you should get started. Atharva says 9, okay. Quickly guys, all of you. There is no problem if you haven't started, but I want you guys to start. Jitendra, how many questions you have solved? 10. Great. I am new. Okay Ajay, okay, no problem. You just start after this session is over. Okay, now let's get started. Okay, so today's first question is that I want you guys to implement stack using queue. Okay, we know what is a stack. So stack follows what we know, that how stack is formed. So basically stack can be like this, and wherein the last element entered is the first one to be out. It follows a LIFO structure, right? So for example, if you have 5 4 3 2 1 inserted in a stack, then 3 will be the first element that is out of the stack, right? So you have to implement stack, but you don't have a stack, right? You have queue available for you have queues available. Okay, Sheikh Mohammed says 100. Great guys. So now let's get going with the question. Okay, so yeah, great guys. So now you have a queue given to you. Okay, there is no stack available. So we know that what are the operations that are available in stack. There are many operations, but we only deal with right now. We will be dealing with push and pop. So we know it takes constant amount of time, because removing an element, we have a pointer that is top, which is responsible for adding and also deletion. So if we have a pointer that is pointing to the first element, then we can easily remove this element in a constant amount of time. And inserting an element, just we update our top to this position and then insert our new element, right? So push and pop are having constant amount of time. Similarly for queue, the two operations, that is entering in a queue and dequeuing, that is deleting from the queue, also takes a constant amount of time, right? So now what the structure followed by queue is that it follows first in first out. So let's suppose 5 4 3 5 is the elements that are present in our queue. So we will have a front pointer and a rear pointer, wherein front is associated with deleting the element and rear is associated with inserting the element, right? So now let's see. So now let's see how to build a queue if we have what how to build a stack if you have only queue available, right? So if you guys can see, there are two ways with which we can do this question. Okay, so we can either make a pop operation efficient. That means it will be operated, it will be executed in a constant amount of time, and its push operation will be executed in order n, right? So that means that we are efficiently implementing pop, right? Rather, in the next case, wherein we will efficiently implement in a constant time, that is push operation, and pop operation will take order of n time. Okay, so now let's see. Let's suppose, now let's first apply what this pop operation efficiently, then we will see this. Okay, so now the first thing that comes up in your mind, so let's suppose you have a example 5 3 2 4 1. Okay guys, this is the array that is given to you, or the elements that we have. So if we talk about a stack, so now let's suppose you have 5 3 2 4 1. So this will be the first element that has to be removed, right? We have to implement this thing, that if we perform pop operation, that one should be removed, but we don't have a stack, right guys? So now we have queues available. So let's see, if we have a single queue available, let's implement it with the help of two queues. Okay, so if we have q1 and q2, these are two queues available. So what I will do, first, the first element inserted will be here. So the first thing that will be, we will check if our queue is empty. Okay, if our q1 is empty, then insert in that q1. Okay, now the second thing what we will do, we'll just remove it from here and insert it in q2. Okay, so we will insert it in q2. So there is one more thing that we will do, but we will skip it for now. Let's see. So then what we will do, we will just, whatever the elements are present in q1, we will insert those elements in q2. Okay, so that's what we will do. Okay, now we inserted this thing in 5. Now let's suppose 3 came. So we will check again. Let's see here. We will check again. Is q1 empty? Yes, it is, right? We have no element present in this queue. So we will insert 3 here. Okay. So now while inserting, sir, can you please repeat? Okay, sure. Just give it some time. I will repeat it. Okay. So now what we will have here. Okay. So now 3 comes. Okay. Now what we will do, if we remove this thing, right? We will remove this 3 and insert it here. Okay. Now what happens? We are building the same thing here over and over again, right? 5 and 3 are repeated again, right? It is the same format, and if we want to remove an element, 5 shouldn't be the first element that should be removed. Okay, if we perform enqueue dequeue operation here, that means we try to fetch the first element, right? So at that time 5 will be, we will get 5, not 3, but we should get an answer as 3. So what we will do, once we have this, we remove all the elements from q1. Okay, and then insert it here. Okay, so now this will look something like this. So what we will do, we will just remove this 3 and 5 if we insert it in the same order, right? So we remove both these things, but it doesn't make sense again, right? We are doing the same thing again, right? We have 5 and 3 again. This will be removed first, then this will be removed. What we will do, we have q1 and we have q2. So first we will insert 5 here, right? This is the first step that we will do. We will check if q1 is empty, right? If it's not empty, then we will remove those elements. But if it is empty, right, in the first step this 5 will be empty, right guys? This q will be emptied, so we inserted this element. If q is empty, insert. That is the first step we will check. So where will we insert it? In q1. So what we will do, before inserting it, what we will do, we will remove all the elements. Right now we don't have anything in q2. What we will do, we will remove all elements, removing all elements from q2 and insert it in q1. But right now we don't have anything in this queue, so it is not applicable here in this step, right? So after that, what we will do, we will insert this element in. After removing this, then what we will do, we will insert it and remove q1 and insert it in q2. So now 5 has been removed. Now the next time when 3 comes, we will check if q1 is empty. Yes, it is. what we will do, the first thing that we will do, we will remove this element and insert it in here. Okay, so we have 5, we inserted 3. Now what we will do, we will just remove all these elements and insert it here. Okay, this is the first step that I was talking about. So after removing this element 5 and inserting it here, now our Q2 will be empty. Okay, so there will be no element. Now this is the first step that we did. This is the first step that we did. We removed Q2 and inserted in here. Now what we will do, we will remove again Q1 and remove all the elements in Q1 and insert it in Q2. So this is how we will do it. Okay, then we insert 3 and then we will insert 5. Now what happens if a dequeue operation is performed, right? That means we are performing pop operation. So which should be the element that we should get? So we have 5 and then we have 3. So 3 should be element, and we know we will delete from front end and rear will be here. So we will get 3. So this is what we will do. Okay, or this is how we, okay sir, we are following. So what we are following, we have a queue given. So that follows what structure? FIFO. We know that, right? Queue follows FIFO. But we have to use this FIFO and have to implement LIFO. That is last in first out, like a stack. Okay. Now if you observe carefully, we are doing this removing Q2 to Q1 and removing, then again we are removing Q1 and inserting it into Q2. Right? If you see, we are doing this operation multiple times. If we can remove one of these conditions, maybe if we act smartly, maybe if we can remove one of these, so that our complexity will be less, right? We are unnecessarily swapping the elements from Q1 to Q2. So what we will do, there's another slightly different approach that we can implement it here. Okay, so what we will do, we will try to remove this Q1 and then inserting it to Q2. We will try to remove this thing. Okay, so how will we do that? Basically what we will do, once we have this 5 inserted in here, Q1, right, in Q1, and our Q2 is empty. So what we will do, we will first remove all these elements and insert it here, right, in Q2. We will check if Q1 is empty, then insert. We inserted our element. Then what we will do, we will remove all elements from Q2 and insert it in Q1. Right now we don't have anything, right? So for this thing to happen again, this Q1 should be empty, right? That's what we were doing here, right? This Q1 should be empty. Now if we somehow swap these Qs, right? If this is now Q2 and this is Q1, now we have the same condition as in the first iteration. This thing happened. In the second iteration, we have our Q1 again empty, right? So we successfully removed this removal of Q1 to Q2, right guys? How smartly we remove this thing. So after that we have Q1 is empty, right? We will insert our 3 in there, right? So we insert our element 3 in here, and once we have inserted, we will after that we will remove all these elements and insert it here, right? So now what we will have after that, again we will swap these. So Q1 becomes this and Q2 becomes this. Again we have Q1 as empty, right? So this is how we implement this. We have successfully removed this one swapping condition that we were doing. So removing all the elements from Q1 to Q2. Now let's see the code of it. So we are implementing our pop efficiently. That means this pop should take constant amount of time. If you see the pop function here, we are just removing from elements from Q2, right? As you can see, in the end, the elements that we were storing was in Q2, right? So we are having Q. How can I attend previous sessions? So once the session is uploaded, once you are subscribed to our channel, right? So after that, you will get some options in the YouTube, right? In our channel, wherein you will be able to find the playlists. Okay, you will find all the sessions there. Okay, cool. So now if you can see, all the elements are present at the end are present in Q2. So now if you just remove the element here, we are performing remove operation. That is removing an element from Q. That we should know. We all know that all the elements are present in Q2. So removing that, we will get this pop operation in a stack in a constant amount of time. That's it, right? Now we haven't implemented this push option efficiently. What do you mean by this thing? Basically, Now let's see. First, what we did, we inserted Q1 in, we inserted the element in Q1. That's what we did. 3 came, we inserted it, right? Now Q2, we checked if Q2 is empty. Right now it is empty, so this condition won't be executed. Then what we did, we just swapped these, just like we swapped two variables, right? Int x is there, and we store this. If we have a temporary variable temp, right? We stored x in it. Then what we did, we initialized x to y, and then y equal to temp. This is how you do a swapping. So same thing we are doing with queues. So we are swapping. This becomes Q2 and this becomes Q1, right? So here you see we are doing that swapping so that we can successfully remove that removals, right? Removing from this queue to this and inserting the element to the next queue. We removed that swap that we were doing, one extra swap, this removing Q1 and inserting it to Q2 with the help of what? Just by swapping. We just did swapping here, okay, so that we can remove this thing, unnecessary thing, okay. So that's what we did. So next time when 3 came, or when 5 came, let's suppose now 5 came, so we inserted our value in 5, right? Then what we did, our Q2 is not empty, so we removed elements from Q2 and inserted it in Q1. So 3 is removed and inserted in Q1, right? This is removed. So this is a step. Now we checked, is our Q empty? Yes, it is, right? So our Q2 is empty, right? So after that, this loop will be exhausted, right? This while loop. Then what we did, we swapped again. So now this becomes Q2 and this becomes Q1 in this swapping, right? So now again, let's remove this. So this is empty again. So we again inserted our element, right? Now let's suppose 3 came, then 5 came, then 6 came. Now 6 will be inserted in Q1, right? Then what we did, we just removed all the elements from Q2 and inserted in Q1, right? So first 5 will be removed, then 3 will be removed. Then what we did, then Q2 becomes empty, right? Then again we swap this. This becomes Q1 and this becomes Q2. Here we swap them. Now if you observe carefully, though we are implementing it using a queue, but the first element that will be removed is 6. That's what we were looking for, right, guys? So we have 3, then we have 5, then we have 6. If we perform pop operation, this 6 will be removed, right? Right? So we have implemented our stack, right, with the help of 2 queues, okay? So now similarly, if we want to then remove, we will again be able to find 5, right? Then 3, right? So because we are removing from Q2, right? This is the pop that we are performing and this is the push that we are performing. Now this takes an order of n time, right? So this is a pop efficient approach, okay? Now is there a push efficient approach as well for solving this problem? Yes, there is, okay? Now let's see how that is executed. So now if you see, now we are just efficiently implementing push operation, okay? So now this takes a constant amount of time. As you can see, we are just inserting our Q1 we are just inserting directly in Q1, that is Q1. So let's suppose we have 5, 3, 6 and 7. We have inserted all the elements in Q1. Now what we are performing, now if we have, now our Q2 is empty. Now how we perform pop, we will remove all the elements, you see. Now what we will do, we will remove all the elements except one. So this will be removed and inserted, Q1 dot remove, and inserted in Q2. So 5 will be removed and inserted in here. Then 3 will be, because front was pointing here and rear was pointing here, right? So we updated our front and then we removed 3. We updated our front and then we removed 6. Okay. Now we have removed all the elements in Q1 except this one. Okay. Now what we will do, we will just remove 7, or you can put it in here in a variable, and so that you can return that variable as well, right? Or you can print that Q1 dot remove. Okay, that can also be done, right? So that we will know, okay, 7 has been removed and this is the last element that we should have. Okay, now if the same thing is implemented in stack, what should be the value? 5, 3, 6 and 7. This is how our stack should look like. So the first element that once we will apply pop operation, so we should get 7. We got our 7, right? We removed all the elements except one. Now Then what we did again, we swapped these values. Now this is removed, right? This is removed. So what we did again, we swapped these. So this becomes Q2 and this becomes Q1. Okay, after removal. So Q1 is empty. Okay, so now Q2 is empty and Q1 is having all the elements, right? 5, 3, 6. Okay, now next time if 8 comes, we will first insert it in here. Then what we did, we swapped all the variables in Q2, right? This is our Q2. Now this is the new Q1. So we swapped all these variables one by one. 5, 3, 6, except this 8, right? This is removed, this is removed, this is removed, except this 8. So we will remove 8 because 8 was the last element that we inserted, right, in a queue. Now this is not present in the stack. Now this should be the 8. Now we get our answer as 8. Now we again swap this. You see how efficiently we now implemented our push operation, and our pop takes order of n time, right guys? And this takes a constant amount of time, right guys? Quickly give me a confirmation. Are the both approaches, the pop efficient and the and the pop efficient as well as the push efficient approach clear to you guys? Quickly give me a confirmation. How to prepare for a complete program as a perfect way. So you have to start while I answer the question of Gaurav. You guys just quickly give me a confirmation that both these approaches are clear. So Gaurav, there sorry. So how to prepare for CP as a perfect? Okay, Kishore says no repeat again. Okay, is there anyone who wants me to repeat this? Okay, Ajay says yes. So Gaurav, there is one simple approach that you can follow, is that you just solve questions. So now first you need to know one simple language, right? It can be Java, it can be Python, whatever you are comfortable with. So after that you just know all the data structures that we have, right? Arrays, stacks, queues, linked list, heaps, hash tables. Hash tables are very important. Okay, then start solving questions on lead code. Okay, then once you have solved some easy level problems, then you go into the HackerRank or HackerEarth, wherein we have hackathons, right? What a hackathon means, or what a CP, it is similar kind of a thing. So basically hackathon can go on for a few days, right? Therein you have to submit your all the projects, and first there is coding round, then you have to submit your projects as well. So that can go from one minimum hackathon is of 1 day. That means same there will be only coding round, or some of them extend to 3-4 days, right? Now these are long-term CPs, right? So these are long-term. So long-term, but what I mean by long-term, that they will go on for 3 days. If you there are some short terms as well that we do in a single day, right? So those are also CPs, right? So first, where to start from a language. You should have one language wherein you can easily implement all the things, right? So let's suppose Java, you should know in and out of Java. So just the basic stuff, rest you can follow up. And then with the data structures and how to implement those data structures in that language. So once you are done with that, you can start coding on lead code or gigs for gigs. Okay, so do we need to have a team? Not really. So some of the hackathons are individual level hackathons. Some are there also wherein you have to build a team. Okay, so now is the question clear? Afrin, all of you guys, please just give me a confirmation. So what we were doing, who said repeat? Kishore. So Kishore, what we were trying to implement, we are trying to implement push and pop. So the push and pop operations are available in stack, right? We know that, and both of them take constant amount of time. But we don't have a stack. We have a queue. So we have a queue. Now what we did, we just implemented with the help of 2 queues. We implemented those operations for both push and pop. Now if you can see, we can either implement push efficient or a pop efficient. Why? Because basically we need to do a trade-off, right? Now where to know what to use? Okay, so let's suppose in your program 70 or 80% of operations are push and 20% are pop. So it's better to implement what? Push efficient approach, right? Because you will be taking constant amount of push and order n time for pop operation. So you have to see if you are implementing more push operations, and then you should go for this. If number of pop operations are, let's suppose 70, then go for pop efficient approach, the earlier approach. Okay, so these are 2 things. So now we have implemented. Now you'll be thinking, sir, is there any way we can skip one of the queues, or how we can implement queue using how we can implement stack using a single queue? Now let's see that. So basically now what we will have here, we'll be having only one single queue. Okay, so let's name this queue as one. So now this question was asked in Google, guys. So this is this, some of you guys might be thinking, okay, why we are doing this simple question. This was asked in Google, right? And you can't go directly to solving a question like this. So you cannot I mean to say, this is very hard to go from without using two stacks, without using two queues, and directly go to a single queue. You need some time for that if you haven't seen any question, right? If you haven't seen this question before. So that's why I told you first two approaches, right? Wherein the first approach was that we use two queues. Now we can easily switch to one queue. Okay, that's the reason I was going for first two queues, and now we will implement this in single queue. And also you should be able to know what how you can be efficient. You should not only know the one way that you can only implement push or push efficient, right, or pop efficient. You should know the both ways, so that maybe sometimes there will come a case I will show you in the next session wherein these operations are very important. Okay, right? So now let's see how to implement this using a single queue. So now basically what we did here, can anyone of you tell me, is this a push efficient approach or a pop efficient approach that we have implemented? Obviously we have implemented in with a pop efficient. That, as you can see, we have why do we code? Okay, CB, you code because in order to get a good decent job, coding is always there. Even though you might be thinking, okay, I am with on data science side, right guys. So even if you think you are in data science side or ML side or AI side, still there will be one round associated with each I mean to say associated with each company wherein you have to code. Okay, the first round will be, yeah, pop efficient. Great. So as you can see, we are just removing from the Q1. Okay, now let's see how we did it. So first we entered the elements here, right? Let's suppose we have 5. Okay, then now what we did, basically what we are doing, we are calculating the size. So right now Q1 is of size what, 1. So obviously Q1 length will be contain 1. Now is the length greater than 1? No, because it makes sense. Why? If we try to remove this is the element we should get, right? Yes, exactly, because we love to code, right? So that is also there, but one should look to all the benefits that you have. If you are basically able to code, you can get easily Amazon, companies like Amazon, Facebook, Google, and right now also Amazon, Google, Facebook, all of these are hiring women. Okay, so basically there is going to be so basically it is in order to maintain a ratio between the number of male candidates working there and the female candidates working there. So basically they want to maintain that ratio. Okay, so for women it is a great opportunity, and all of the things are happening online. So if for all the girls or all the female students, those can easily I mean to say crack these interviews, because all the candidates who are facing, I have seen one of my friends who got selected recently. She was a girl, and all the things that happened online, there was nothing obviously right now we are in the situation where everything happens online, right? So all the interview happened online and she got selected, or maybe she has gone through 3 rounds. Yes, maybe 3 rounds, and she has qualified all those 3 rounds. Okay, so there will be one more round, I guess, 1 or 2 rounds. So basically all the things that you know, that all the interviews were only SDE1, and after that there was SDM, right, the manager. So basically SDE1 was someone who had joined recently. So you see that guy might not be having that much experience, right? So you can easily crack those things. Right now we are in a situation where Amazon, Facebook are hiring girls, right? So you can easily take advantage of that thing. Okay, so now let's go back to the question. Okay, so now we have Q1, right? So this 5 is there, right? So now Anshika Gupta, yes, that is also there, right? So she's also there, yeah. So now if you see the length is not greater than 1, so this is the if you now perform a pop operation, this 5 will get out, and this is the element that we have want, right? Now let's suppose there came 6 and we inserted 6. Now the length is greater than 2. Obviously the size of this is greater than 2. Now what we did, we removed the first element and inserted it back into the same queue. So we removed this and inserted in the same. So if you can see, if 5 and 6 are entered in a stack, 6 should be removed first, and now front is are here and rear is here, so we can easily implement this thing, right? And we decremented the length once we have now you might be thinking why we have used this length and why not this size, because size will remain same, guys, right? So we are not decrementing the size. Size is always 2, or whatever the elements are there, size will always remain same. So length we are decrementing. So basically we are performing only those many removals from the queue that we just leave one element there, okay, which is not swapped. So let's suppose we were having 2 elements, we removed 1 and 1 is already there. Now let's suppose we have another element that came, that is 4. Now what we will do, we will remove this and insert it back. One removal. Remove this and insert it back, right? So 5. Now if you can see, if this is the 4 is the element that we inserted just, so this should be the element that should be present, we should be able to pop, right, guys? So this is how you do it based on the length. Then we decrement our length. Okay, got it, guys? So this is how you perform it, implementing only one queue. Okay, one single queue. Now what is your assignment? I want you guys to, obviously you can just implement it. Right now we are having a constant amount of time, right? We are removing elements up to the length minus 1, n minus 1 elements are being removed. Obviously the time complexity of this is order of n, and if you calculate the time complexity, it is constant, right? So you can easily, now what your assignment is, small assignment, you can just implement, now you should be able to implement pop efficient. That pop should take constant amount and push should take linear amount of time. Okay, so this is your small assignment, just go through it. Okay guys, quickly give me a confirmation, yes, no, maybe, quickly guys. And you all of you give me a confirmation that whatever we learned so far is clear to you guys. Quickly, Abhishek, Deepa, Kishore, Sibi, everyone, quickly guys, yes, no, maybe. Afreen says yes. Okay, so any one of you want me to repeat? Anyone? Yep. Okay, great. This is easy question, but it was asked in Google, and you might be facing, any one of you, sooner or later you will be facing this question. Either they just usually what now, this is a easy level, since this is a easy level question. So usually when an interviewer will ask you, he doesn't know if you know the things, right? He doesn't want you to code this thing, but you should be able to give him both the approaches. Okay, so once you have implemented it, then he won't be able, he won't ask you to code everything, right? If you say okay, I will implement it using push constant or pop constant, then it increases your chances of getting selected. Okay, but Google and Amazon will not repeat this, but maybe other companies are there, right? So they might implement at that time. You might be having a chance there in the other companies where you will be facing this question again. Okay, cool guys. Now let's see the other question. Now what we are trying to implement, now we are implementing queue using 2 stacks. Okay, so this was also asked in Google. This is an easy level question. Both of these were easy level. So today I have focused on easy level questions, but very important. Okay, so again we know stack will take constant, push will take constant amount of time. In stack, push and pop will take constant, and QDQ will take constant amount of time, right? So now how to implement it using 2 stack. So again, both these approaches will be implemented, NQ efficient or DQ efficient, right guys? We know that. Now let's see the first approach. Okay, now we are having 2 stacks, right? And we are trying to implement a queue. So basically what a queue is, 5, 6, 3, 1 and forward. Now if you want to remove, we will remove from front, and if you want to add, we will add from rear side. But now we have 2 stacks given. This is S1 and this is S2. Okay guys, now if you can observe carefully, this is a DQ efficient operation. Okay, So we are efficiently implementing dequeue. That means we are just removing elements. If you see s1.pop, so we are removing just one element from the stack, okay, in from s1. Okay, now you can see. Now let's see how this thing is implemented. Okay, this is a constant amount of time as it is a dequeue efficient. Okay, constant. Now what about this thing which takes order n of time? So now once let's suppose this 5 came. Okay, you saw, is s1 empty? Yes, it is. Okay, if s1 is not empty but s1 is empty, so there will be nothing, this while loop will not be executed, right? And we are straight away pushing the element, so 5 will be inserted in here. Then what we did, we checked, is s2 empty, is s2 not empty? If s2 is not empty but if s2 is empty, so this will not be executed, and we are removing from s1. We can simply, if somehow you are performing what pop operation, you can easily remove from this element, and that takes a constant amount of time, right guys? Now let's suppose 6 came, right? We check, is my s1 empty? No, this is not empty. S1 is not empty, right guys? So what we did, we removed this element and inserted in s2. So 5 has been removed and inserted in s2. Now what we did, okay, now the stack is empty, this stack is empty, s1 is empty, so we will go out of this loop. Now we pushed our element in here, right? So this is our element, what, 6, right? Now after we pushed in our element here, what we did, is our s2 empty? No. What we are doing, we are removing this thing and inserting it in here, right? So now we have 5 in here, right? We removed this and inserted in here, and once we removed this, after that we pushed it in the s1 stack. Okay, here is it. So now this is stack. Now in queue, if we are having 2 elements, right, 6 and 5, so which element should be removed first? If we have already removed what? If we have already removed this. So, okay, right? So now, yes, sir. Okay, cool guys. So now how we did it? So now let's suppose another element came, right? So now let's suppose 3 came, right? So now we checked, is our stack s1 empty? No, it is not. So what we did, we removed elements. So 5 will be removed, it will be inserted here. 6 will be removed, it will be inserted here. Okay. Then what we did, after that we pushed 6 or 3 into this stack. Now we checked, is our s2 empty? No, it is not. So what we did, we inserted back 6 here and then 5 here. Okay. So now if you can observe, we had 3 elements, 5, 6 and 3, and in our queue, in our stack, what are the elements available, in which order they are available in our, if we represent this in a queue, so the first element that will be removed is 5, right? This front, this is red. If you can see what is the top 3 elements of the queue, so if you want to remove, if pop is performed, 5 will be removed, right? We have 5 in here, so we are done. 6 will be here, right? And 3 will be here, because we are removing always from s1, so s1 will contain it in the same order, right guys? So now what we are doing, basically we are adding it, we are inserting, we are first what we are checking, if our s1 is empty. If it is not empty, we are pushing all the elements in the s2. Okay, removing s1, all the elements from s1 and pushing it in s2. That's it. Now then after that, once it is empty, we inserted 5. Okay, so if it is empty, we inserted element 5 in it. After that, what we did, we just again removed those elements from s2 and inserted all of them in s1. And after that, we are just dequeuing elements if we want. Okay guys, so this is fairly simple, right? The dequeue efficient approach. Quickly, yes, no, maybe. These are very important questions, guys. This might be, you might be feeling, okay, this is fairly simple, we can do it, but there's a logic behind it that we will be covering in the next session. But these questions are very important. Quickly, confirmation, guys. Yes, no, and once the session is session is over, please go once who are new, okay, please subscribe to our channel. Then you will get the playlist for all the live sessions. Okay, Okay, Gaurav Kumar says repeat. So basically, Gaurav, what we are doing, we have two stacks, okay, S1 and S2, and we are trying to implement a queue. So basically, queue will contain six. Let's suppose queue will contain 6, 3, 4, 1 elements. This is our queue. So we want to implement this queue. So if you observe, now we are inserting in the same order, right? Let's suppose we have 5 and we inserted in S1, right? Then what we did, if we want to remove, our pop operation is efficient, right? This is a dequeue operation. Our dequeue operation is efficient, right? So we just remove from S2 if only a single element. If we just remove from S1, we are having only single element in. Now let's suppose 6 came. What we did, we first removed all the elements from S1, right? So let's suppose if you haven't removed it, if these two elements were present in such order, right, we inserted it and so on. So now we will be having 6 our first element, but that should not be the case, right? We should get 5 as the first element that should be popped, right? So we have to use another stack. So what we did, we just removed this 5 first and inserted it in S2. Then after that we inserted it, our new element that came 6 in our stack, right, S1. Now after that what we did, we just again removed all the elements and inserted it in here. Now if you see, if we perform two pop operations, we will get 5 and 6. That was not the case earlier. We were getting earlier the invalid results. Now let's suppose 4 came. Now 4 came. First we checked, is this stack empty? No, it is not. What we did, we removed this element and inserted it in here. So how we removed this? We inserted 5, we inserted 6. That's how we insert, how we remove top, how we only have the top element, right? We are implementing it in a stack. So both these elements are removed. Now we check, okay, this stack is empty now. So now let's insert our 4. So once this 4 is inserted, now what we did, we just removed this 6 and inserted it back. We removed 5 and inserted it back. So now if we perform pop operations 3 times, we'll get 5, 6 and 4. That should be the case, right? In queue, we should get 5 first, then this is the front, this is the rear, right? So front will be updated, we will get 6. Front will be updated, we'll remove 4, right? So this is how we did it, right? If you see the code, that's the thing that we did. We removed first from S1, then inserted it back. We removed, then we inserted, then once the stack 1 is empty, we inserted our new element in stack 1. After that, we removed all the elements from stack 2 and inserted it back to stack 1. Now this is a dequeue efficient. As you can see, we are taking constant amount of time, right? Sorry. Can we do better, or can we efficiently implement NQ operation? Yes, we can. So if you can see, we are just so let's suppose we have a stack, okay, S1. Now what we did, we just inserted all the elements 5, 6, 4, 1 in our stack. So that's what we did here, right? We are inserting our dequeue operation. Our NQ operation is efficient, so we are just directly implementing it in S1, okay? So directly inserting in S1 NQ operation, right? Now what about dequeue? So how dequeue works, now our S1 will contain all the elements, right? 5, 6, 4 and 1, right? Because we are let's suppose we are performing NQ operation 4 times, insert, insert, insert. So this is what we get in our stack, right? 5, 6, 4 and 1. But now what about pop operation? If we perform pop operation on this S1, we will get invalid result, right? We should get 5 as our answer, but we only have access to this top, right? So what we did, in our new this is our S1, and in our S2, what we did, is S2 empty? Yes, it is, right? This is empty. While S1 is empty, now we are starting removing the elements, okay? What we did, we just removed this S1 element from S1 and inserted it in S2. So 1 has been removed and inserted here. 4 has been removed and inserted here. 6 has been removed and inserted here. And then finally 5 has been removed and inserted here. Once all the elements are removed, our S1 is empty, right? Yes, because S1 is empty. Then what we did, we just popped out the first element, 5, and that should be our result, right guys? So this should be the first element that should be removed if we are talking about queue. So how would we insert? 5, 6, 4, 1, and option should be here, right guys? So this is a push or what you can say NQ efficient, because NQing takes constant amount of time and dequeuing takes order n time, right guys? Because we are removing all the elements, you see, remove this, remove this, remove this. So whatever was the count of elements, that is 4, we removed it and inserted it in that. Okay, fairly simple, right guys? Quickly confirmation, sir, S2 popped. Then again, if we have if we want to pop the next element, so now if we want to pop the next element in this, so there are multiple approaches, Abhishek. So this is one of the approaches. So what we are doing now, S2 is we have popped the first element. Now what happens now, if we are removing again, so what we are doing, we will check, is S2 empty? No, it is not, so this won't be executed, right? So S2 is pop, whatever is the top element will be removed. So we have removed 5. Now what we will be doing, we remove this thing 6. Okay, Abhishek, we remove this at 6, so we will get 6. After that, is S2 empty? No, it is not. We will remove again, we perform pop operation. Okay, we will get 4, and we will get 4 as our output. Now let's suppose now this stack is not empty, and we encountered another NQ operation, so that will be present in this queue, right? Let's suppose 10 is there. So again, still we are having elements in this queue, right? So yeah, you got it, great. So now we have again S2 is not empty yet, so 1 will be our answer, right? Great. So now let's suppose you entered again, there is 11 that you inserted, so 10 and 11 are present in S1. So because S1 is always responsible, and this takes a constant amount of time, right? Now what you did, let's suppose now S2 is empty, right? So now what we did, we just removed again elements from this and inserted in this 11 and 10. Okay, now once this S1 is empty, and we are exhausted from this while loop, and then what we perform, pop operation, so 10 will be removed first, as 10 was inserted first. Got it guys? Quickly confirmation guys. Now both these approaches are clear, right? How to insert a DQ efficient, how to perform DQ efficient approach, and how to perform NQ efficient approach. Now this is a little bit tricky question. Okay, so now in order to implement this using one stack, what we did, we have an approach here. Basically we will be using recursion. Okay, now some of you guys might be thinking, okay sir, recursion will also take a constant amount, take up a stack. But yes, so there is no way we can implement it, or there might be, but what we did, or what I did, so basically I used recursion. So some of we will be having a recursion session as well soon we'll be having recursion. For now, since we want to cover this thing as well, so that's why I have used recursion here. If some of you guys will not be able to understand, so go through it once or twice. So let me just show you one simple thing first. So let's suppose you want to print an element from 1 to 5. Okay, you want to print it 1 to 5 using recursion. So how would you do it? Let's suppose you have function print, which takes n as argument. Okay, now so the first condition is that you will be having some base condition in a recursion, right guys? So let's suppose that base condition is if n is let's suppose less than 0, then return. Okay, else SOP, that is system.out.print, right? Okay, let's suppose we want to print it in a reverse order. Okay, so we printed n, and then what we did, we recursively called, that is what do you mean by recursion? Function calling itself. Okay, what we did, n minus 1, this function is called again. Okay, so now what happened here? So we want to print elements in a reverse order, so 5 should be present first, then 5 should be printed, 4 3 2 1, right guys? So this is the output that I'm looking for. Now this n contains the number, right, that 5. So is 5 less than 0? No, this will not be executed. Now SOP 5 will be done, 5 will be printed. Then recursively this function is called again, but on the value 4. Now 4 will be printed, right guys? It will check and then prints, right? Just follow along a little bit. I want to show you something. Now again this will be called on 3, right? So 3 will be printed. Now again on 2, then 1, right? So this is simple program which prints a series in a reverse order. But what if we want it in order 1 to 5? What should you do? Do you have anything? We just change this thing. We'll just remove this pop operation SOP, that is printing here, and put it here. That's it. Now what happens? Now listen to me carefully, very carefully. So we will go through it very sir, I am leaving this class because I have some work. Okay. Okay, Gaurav, you can always come back to the session once it is uploaded. Okay, so basically what we did here, so once we have, now what is the output that we will be getting? Okay, you can leave, Gaurav, if it is that important, but we will be finishing it just in 10 minutes. So if you want, you can just stay for 10 minutes. Okay, cool. So now we are printing, we have 5. Is 5 less than 0? No, SOP is not here right now. Okay, this SOP condition is not. So why? What happens now? This 5 is left, this printing statement is left in the stack. Okay, rest of the statements are executed. Now there will be again all the statements for 4, this is for 5, this is for 4. All the statements will be executed except this println, because we are calling our function again here, right? So it will be called on 3, all the statements, right? What I mean by statements is that this and this will be executed, right? It will check, and then it will call the function again on 2, on 3, right? And then this printing statement is left, right? This 3 is left. Now it will be called on 2, all statements will be executed, 2 is left, the printing statement is left, right? These are the printing statements left. Now it will be called on 1 and all the statements will be executed. Now again it will call on 0, right? Its printing will be left. Again it will call on 0. Now it will return. Now once it will return from the 0, right? So this will remove from the stack. Now its printing statement is left. So 1 will be printed. Again it will be popped out of as soon as it reaches the end of the statement. There are 2 ways that you can return to a program. Like we returned here because we have explicitly written return. That happened in this 0 case. Now in case of 1, as we have exhausted all the statements, also then it will return to the previous call stack. Okay, so now 2 is printing statement of 2 is left, so 2 will be printed. It will go back, it will be popped out the stack, it will print 3. Printing statement was left, printing statement was left, printing statement was left, 4 and 5. Okay guys, so you see how we just removed this SOP that is printing from here to here, and we got the original order that we were looking for from 1 to 5, right? So this is fairly simple. Now what we are doing in here in this approach, okay, so basically this is an NQ efficient, that means it takes a constant amount of time here, right? Now what about the DQ? So basically we have one stack, okay, let's suppose, and we have the Q elements are so basically NQ will take constant amount of time. Let's suppose we have 5 6 4 1 in our queue. So we inserted all the elements here, right? 5 6 4 1. Okay, now how to perform pop operation, as we have only one stack. Okay, what we did, we checked, is the s1 dot size equal to 0? That means we are trying to remove something that is not there. So this is the underflow condition. Also guys, keep a good mean to say, you have to be very focused when you are trying to implement stacks and queues about the underflow condition and overflow conditions. So overflow conditions won't be there one if you are implementing it using this we have implemented using this collection class, right? Collection framework. So at that time it is implemented through linked list, so overflow is gone. But underflow, you have to put those conditions in the picture as well. So here underflow happens, right? We are trying to remove and the size of the stack is 0. That means there is no element, and we return. Now if the size of the size of the stack is only one element is present, right? So we will just return that is the element that we were looking for, right? There is only one element. Okay, so that will be our answer, right? So now what happens, what we are doing here, right? So if you see now what we are doing, so both these conditions will not be executed, right? So now what we're doing, we are inserting D, we are putting D, and we are popping the first element, and that should be present in D. Okay, this is our call stack. Okay, now what happened, we are returning the value whatever is returned from DQ. So you see here we are calling this DQ again. Okay, and its push is left and return value is left again. Okay, so now these two conditions are left. Okay, and now what we are doing, whatever is returned here will be inserted in here. Okay, now it calls the function again. Now in here, let's remove these elements. Okay, let's suppose we have only 5 and 6, so that our call stack looks a little smaller. Okay, so 5 and 6. Okay, so now okay, so we have 6, so whatever will be R in a D, it will be 6. Okay, now it will be called on what, on D. Now let's now this is removed from the stack. Okay, now we have 5, right guys, we have 5. Okay, so now is my s1 dot size equal to 0? No, there is one element. But is my this s1 dot pop 1? Yes, it is. So now it is 1, the only one element is there, so 5 will be removed, 5 will be returned. So 5 is returned to this function D. So 5 is removed and it comes in D. Now what is the return value that D, not here, sorry, return value is present here, that is 5. Okay guys, now what we did, we pushed that D in our stack. Okay, now we pushed that D in our stack. Earlier we have removed this 6. Now what we did, just a minute guys, so 6 was removed, right? So what we did, we just pushed that D in our stack. So D contained what, D was 6. So now we pushed our D in a stack and we returned the value, because that was the removed element, right? 6 was inserted back in the stack and we returned the value, that R value was 5, so we returned 5. You see, it might be a little bit confusing, but if you just dry run it out, it will make sense. Okay guys, so this is how you do it. So basically what we are trying to do here, we are just trying to implement what, we are just doing this thing. So there was 5 and there was 6. Now we removed this 6, but it was left in that call stack. Okay, it was left on that call stack unless and until we get to this point. Once we got to this point, we just let's suppose there was 5, 6 and 7. 7 will be removed, 6 will be removed, and then 5 will be removed. So we got the 5, right? Now all these elements are left on the call stack, and when they are on the call stack, we are inserting it back to the queue. Okay, we are inserting back in the stack. Okay, so 6 will be inserted back and it will remove from the call stack. 7 will be inserted back and it will be present in the stack. Now it will be inserted back. Okay, got it? Sir, what is the best practice to implement these? So the best practice is now you know the intuition, right guys? So all of you got this intuition, right? So now what you should do, go on to Geek for Geeks or Lead Code and implement it. Simple. That is how you learn. So go through all the sessions, whoever is new, implement all those things, and on Lead Code now you will get enough time, right? That's why there is a huge gap between session to session, almost 6 to 7 days, right? So everyone got this intuition, right? The intuition of this approach, implementing stack using only one, implementing queue using only one stack, right guys? So just go on to Lead Code and start coding. If anyone is new to this, I mean to say having first session, you should definitely go through all the series. I will highly recommend it and implement it. Not learn all the, I'm not saying watch all the parts, just watch one part and implement it. Watch second part, implement it. So you have almost 6 days until the next session. Okay. Okay guys, just give me a confirmation that this approach was clear, and I want you guys, maybe recursion is not covered yet, but I wanted to show you this because this is very important approach. Okay, so maybe when we cover recursion, after that it will be much clear. Okay, but for now, let's suppose some of you know recursion, then please dry run it out and you will get to know the answers. Okay, how this works. So basically intuition is same, that we are removing, it will be present on the call stack, we are inserting it back, just like that example that I showed you of print, right? Same thing is happening. Okay, great guys. So just quickly give me a confirmation. Okay, we have, yes, it is clear. Great. So this is the I'm concluding. Okay, yes, this is my first session. Okay, so now do one thing. I recommend you to go to the part 1 and think how you can implement all, start learning and implementing at the same time. Don't just keep learning, don't fall in the learning loop. I always say this thing, just implement it. Okay, so thank you so much guys. I will conclude this session right here, right now. For now, maybe in the next session we will cover recursion and then backtracking, then DP. Okay guys, just give me a quick confirmation. Okay, great, guys. So thank you so much. Thank you, Afreen, Sonu, Abhishek. Thank you so much, guys. So I'm concluding this session. Thank you, guys. Thank you so much.